So this is another simplification question because there's no equal sign, and this is question 3P from the review. So we have 24a squared c multiplied by 3a squared c negative 1 plus c cubed to the 18 or over 18. And so we could go right ahead and just multiply our 24 by the 3 and then plus the c, because really this is over 1. But what we could also do too is reduce the fractions we're given. So and that's what I've actually done in the review solution. So if you notice, we have 18 and we have 24, and a common factor between the two is actually 6. So if I actually divide both by 6, I actually can reduce this down. So it'll become 4a squared c. We still have the brackets a squared c negative 1 plus c cubed, but now I have it over 3. And so you don't have to do this right away. However, when you're simplifying and you're given fractions, you should always have your final answer in its simplest form. So I'm just sort of kind of taking out some of the busy work, if you will, for later. So now I'm going to go ahead and just multiply my like terms. So we have a 4 and our other like term is a 3. So 4 times 3 gives us 12. And now we've got, we're multiplying with our exponent laws. We have a common base of a, okay? And so when we have a common base, we then add the exponents together. So 2 plus 2 gives me a to the 4. And c by itself here actually, when you just see a letter by itself, it is always to the exponent 1, or even a number for that matter, because it's just assumed that we recognize that to be c to the power of 1. So I have a positive 1, but I'm also taking away 1. So really that's going to be 0. Or c to the exponent 0, but that's one of our exponent laws, where any exponent we have that's 0, automatically the base is going to be 1. So that's why at the end of the answer we don't see that there anymore, but I'll keep it there for right now. And then I'm multiplying the same thing again for that positive c cubed. So everything remains the same except for the c, because now I have c1 to the exponent 1, and I'm adding 3 to it, so it actually becomes c to the exponent 4, and then I have it over 3. So our final answer actually will be 12a to the power of 4. Remember, that gets canceled out and becomes a 1, so essentially it's 12 multiplied by 1, which is still 12, so nothing really changes. And then we have 4a squared c to the power of 4 over 3. Now, keep in mind, the reason why this is in its simplified form is, yes, technically we could divide the 12 by the 3 to get an even number, but the reason why the solution doesn't do that is because the 4 does not divide evenly into the 3. So when we look at this as a final answer, we could also look at this, just to put it up here, is 12a to the exponent 4 over 3 plus 4a squared c4, sorry, I run out of room there, over 3. Okay, so yeah, we could say that it's 4a to the power of 4 plus then this fraction. We could do that. That's just a different approach, but the reason why I did not do that is because the 4 does not go into the denominator evenly, so that's why I left it. I left it as is. So I hope this clears up any problems.